Hello and welcome to this tutorial video. Today what we're going to be doing is creating a drifting scoring system. So whether you want to add drift to your game or you want to add it as a mini game, this tutorial is going to show you how you can actually create the drifting system you can see here, which basically has ways to increase the multiplier of your drift. It will find the angle of your car, and it will cancel the drift if you're not going fast enough or your angle is too mean. So if we stop, it stops the drift. Before we get started on the video, I wanted to let you know that I've created a new Discord channel where you can ask any questions you have about the videos or about game design in general, and you can find other like-minded people that are pretty much willing to help you, and if they're not, I'm there to help. Alright, let's get started. So I took the liberty and I create a very simple UI for our drifting. So you can see there is a total score text here. There is an angle, which shows the car angle. And then there is this game object, which contains the current drift, along with the factor, and the current score. Okay, so what we're gonna do now is create a new script, which we're gonna call Drift Manager. And we're gonna open it. So, first off, we want to see what we need. We want to know our player position and his rigid body. We want to know our score texts, and we also want to know our score. So let's start. First thing is going to be the variable, so public rigid body, which is going to be the player rigid body. Then we're going to have the texts, which is going to be a part of TextMesh Pro. So we're going to have to using TextMesh Pro. So we're going back, TextMesh Pro.text. And so we have the total score text. We also have the current score text, if I remember correctly, and the factor text, and let's see, factor text, and what else? And we're gonna have a drift angle text, true. And finally, current drift text. Sorry, no, we don't need that. Okay. Next thing we want to have a variable to keep our scores, our speed, and our angle. So we start by actually having a private float, which is going to be our speed. Another private float, which is going to be our drift angle, which we can set both to 0. Another one, which we're going to have our drift factor, which is going to be the multiplier. And also one for our score. And finally, another one for our total score. Perfect. And then we want to know if our car is drifting, so we're gonna have a bool for that. So we're gonna have a private bool is drifting, which is gonna be false to start. And then we're gonna have our public variables. First one is going to be our minimum speed that we're gonna need to start drifting. So if you're going super slow, you can't really drift, so we want to have a minimum speed to drift, which I'm gonna put to 5 for now. Also, we're gonna need a minimum angle of attack to be considered a drift, so we can put like 10 degrees. And yeah, we can also have a delay, so when you hit the angle, you can wait like 0.2 seconds before you actually start counting the drift, so it looks more natural. So we're gonna have that as well. Drifting delay, and we're gonna put that to 0.2 seconds. Perfect. Also, we want to have a way to enable and disable the drifting, so the drifting game objects. So first thing we want to add is public game object drifting object, which is basically gonna be disabling this if we're not drifting, like this. And finally, we can also have some colors. So if our drift is good, we can have the color white, but if our drift is, for example, near failing, we can have the color yellow, and if it fails, we can have the color red. So let's add this one as well. So public color, normal drift color, sorry. Also near stop color, and drift ended color. Yeah, that's it. Okay, so first thing we want to do is create two voids, two functions. First one is going to manage our drift, and another one is going to manage our UI. sorry, like that. And we're gonna update them constantly on the update function. So manage drift and manage UI. Perfect. After this, we can basically start creating our drift. So what we're gonna do with the drift is we're gonna have a car, our car basically, which is going to be alongside the rails, for example, sorry. So we're gonna have a turn, for example, and we're gonna have our car, which is gonna be drifting. Hope this seems like a car. It should. Okay. So we have the forward vector, which is where the car is looking, and we also have where the car is spinning. So it's gonna, not spinning, but drifting. So this is the angle of attack. So this is gonna be around 70 degrees for this case right here, or maybe a bit less, like 50. And so we want to calculate this angle here to actually know if we're drifting or not, and how big of a drift we're doing. Okay, so now that we know what we want to do, we start by first of all getting our car speed, so player that reads both the velocity and the magnitude of the velocity, so basically our speed. And then we want to know our speed angle. So our speed angle, if we go back, is basically the forward vector and the angle of the forward vector compared to our velocity vector. So this is the velocity, and this is the forward vector. Okay, so to do that, we put a vector 3 dot angle, which is gonna give us the angle between the player rigid body, the player forward momentum, vector, yep. And we're also gonna have our velocity vector, which is gonna be a player dot velocity, and in case the car is not moving. So if the car is the forward and the car has speed is 0, that's gonna mean that the velocity can be here, 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 whatever Unity decides based on random integers, floating points, and whatever was before. So to make sure that doesn't happen, we can actually add the forward vector. So in case we have 0 speed, the vector is gonna be the forward one. So the player dot transform dot forward. And we normalize it, so basically what we're doing is we're taking the velocity plus a small vector which is gonna be the forward, and we take the normal value of this one, which is basically this value here. Wait, let me do it in red so you can see it. So it's this value here. It's a bit different than the actual color, but it's so close that it fixes a lot of problems that we do not care now. So we normalize it. So we make it a vector with one scale. Okay, and so we have our drift angle. Another thing we want to make sure about our drift angle is if our car is spinning, so if for example this is the turn here and our car, sorry, I have red, and our car is spinning out, so the forward motion is here and the car is going like this is the velocity. Yep. We want to make sure that this is not considered drift. So we check if this angle here, let's call it theta, is bigger than 120 or 90 or whatever angle you choose. And if it is, then theta is going to be zeroed out. So we're gonna do this here. So drift, if the drift angle is bigger than 120 degrees, then the drift angle should be considered 0 for the rest of the calculations, that is. Okay, and now we do the calculations. We start by checking if the car is drifting, and if it's not, we should start the drifting, or at least enable this bool here. Where is it? It's, yeah, this bool here. We need to set this to true. So we say if the drift angle is bigger than our minimum angle, and the car is moving, so speed is bigger than the minimum speed we need, then if the car is not drifting, so if it's not drifting, we start a drift, which is gonna be a function which we're gonna create a bit later. Else, if either of these two, so minimum angle and minimum speed, is not, if we don't have bigger speed or we don't have bigger angle, we're gonna stop our drift. So we're gonna have a function that if we're drifting, we're gonna call the stop drift function. So let's create these two functions. Okay, so void start drift function, and then the void stop drift function. Perfect. Okay, since we want to have a delay before we start the drift, we're gonna set the start drift function as an asynchronous function. So this should be void async asynchronous void function, which is gonna be called start drift. And what we're gonna do is, if we're not already drifting, then we won't start the drift. So we await, and this is gonna be a bit weird as a syntax, but stay with me. Delay. As you can see here, I have an error. So to fix this, we're gonna go here, and we're gonna use the system threading.tasks. What this allows us is to actually have the system make the CPU wait for the given time before it continues reading the rest of the script. So we have the await, the await task delay, and because the system wants it in cycles, we're gonna have to do it in integers. And it basically wants us to give milliseconds instead of seconds. So we're gonna do this, our drifting delay times 1000, which is basically 1 second. So if the drifting delay is 1 second, this is gonna be 1000 milliseconds. And after this, what we do is we set the drift factor to 1 and the is drifting to true. And what we can also do is actually we can set the is drifting to show up like this or like this, since we will not execute this before we actually have waited. And we can actually set the current score text.color to our normal color. Perfect. So now we have initiate.drift, and what we want is to have a way to actually read and increase the score. So we go here to our manage drift. At the end, we say if we're drifting, then our current score should be equal to the time.delta time. So basically, so this, we should say if we're drifting, our current score should be equal to the time.delta time times our drift angle, and our drift factor. So what this basically does is increase our score based on the time that we're drifting, our angle, so the better the angle, the more score we get, and the factor that we have, the multiplier of the drift. Also, we want to increase the factor, so we can actually just do this times the time. And we need to set the drifting object to appear. Okay, so before we test this, we want to actually have a way to show the user the score that he has. So we can actually go to our manage UI and total score.text, and we can actually show him his total score, which is going to be the word total and the total score the total score plus the current score, and all this as a string that's gonna have the form of so what this means is our string, if it's a number, if it's 1000, it's gonna have a comma, if it's 1 million, it's gonna have a comma, but if it's 50, it's gonna have 0, 50 as the way it shows up. So we do this for the factor text.text to be equal to the drift factor dot toString, but this time it's gonna be whatever we say, so like this, but with a comma. So wait, let me see how it's written correctly. 0.0. So this is gonna look like 1.5, for example, 3.5, 1000, 0.5, something like that. And we can also add an X to show that's a multiplier. We do this for the current drift score as well. Text.text equals current score. Actually, we can copy paste this to string to make it faster. And our drift angle, same thing. Drift angle text, angle text, I think. Drift angle text.text is going to be equal to drift angle dot toString. Perfect. So let's try and test this out. We go to the Unity, we go to our canvas, and now we put the game objects and the variable. So we put the car, we put the total score and the total score, the current score to the current score field, factor, etc. So factor, and drift angle, and drifting object is going to be our drifting. And normal drift color should be white, full white. Near stop should be yellow, and red if we stop the drift. Okay, so let's test this out. So you can see this is not disabled yet, but if we start drifting, you can see that it increases the score, and it has the drifting, our current angle right now, and also our drift. But as you can see, it's not stopping at all, so we need to add that. Okay, so before we do that, I want to make a small change to the drifting factor, so I think it should be like this, so it has the angle icon. And so now we won't have the stop and start the drifting. So to do this, what a way I want to do it so that we can have the delay is have a coroutine that's gonna wait until we tell it to actually stop the drift. So we're gonna actually go to our variables and create a enumerator. So we're gonna go here. This is gonna be a private enumerator, which we're gonna call stop drifting coroutine, which is gonna be equal to null at start. So what we can do now is go to our stop drift function and start writing. So first of all, what we want to do is give our stop drifting coroutine something to actually hold. So it's gonna be an enumerator. So we need to create an enumerator. So there's gonna be a private enumerator, which we're gonna call stopping drift. Perfect. So we go here. Stopping drift is gonna be the function that it holds, and we're gonna start the coroutine that we have just created. So on this coroutine, what we're gonna go and do is actually wait. So to do this on the coroutine, we do yield, return, new, wait for seconds, and we're gonna wait 0.1 second. After the wait time, we change the color of the current score text to the wait. Let me see what I have named it, to the near stop color, and then we're gonna wait another few seconds so that we actually cancel the drift. So we yield, return, new, wait for seconds, which is gonna be our drifting delay times 4. I think 4 is a good number. I'm not sure to be honest, but 4 is gonna be a good test variable. And if this passes, then we're gonna increase our total score by our current score, and we're gonna set the drifting to false. Our current drift text, our current score dot color is gonna be equal to stopped color. Sorry, let me find it. So drift ended color, and finally we put the current score to. We can actually put the current score in a bit to 0. So we yield. We wait a few more seconds so that we show the user that his score has been taken, and after that we yield return, new, wait for seconds, so 0.5 seconds, and after that we actually put the current score to 0 and we disable the drift object. Okay, so what we can do now is go back to our drift manager, so the manage drift function. And what we can actually do is, instead of only checking that if we're drifting, we can call the start drifting function if we have a coroutine that's waiting to cancel our drift. So if we have a stop drifting coroutine that's in our function, so if it's not null, then we go back to our start drift. And on our start drift, what we're gonna do is say that if we actually have a stop drifting coroutine, then we stop that coroutine, stop drifting coroutine, and we set the stop drifting coroutine to be equal to none, so that we know that we don't have another coroutine waiting. And finally, here with the is drifting, so that we do not call it more than one time, we want to make sure that we don't have a coroutine right now that's waiting. Okay, so let's see how this looks. So we go back to our game. We see that nothing really has changed here. Also, before we do this, we can actually disable the drifting object before we start, so false. And let's see how this plays. Actually, before we start doing anything and testing it, I have made a mistake. In the total score text, we don't want to show the current score, we want to show the total score right now. So we go here, back to our game. Let's actually test it out. Okay, so we go forward, and in a little bit we're gonna start drifting. So here we start drifting, and as you can see, while we're drifting, the score is increasing, and if we stop, the score on the top left of your screen is increasing. So yeah, that's pretty much it about the drift. I hope you liked the video, and I really hope you found it very helpful. So take care.